Before we even get into drawing the diagrams, we need to know the rules that the light rays will follow as they reflect off of a curved mirror. We will always have dotted line here, the principal axis. The object will always be indicated by an arrow, with the top of the object pointing up and the bottom of the object resting on the principal axis. And there will be a number of light rays that we're going to reflect from the object to the mirror. In reality, light rays are coming from all angles. We just don't have the space to put all those light rays. So the first rule with all light coming from an object to a converging mirror, any light that begins by passing parallel to the principal axis, indicated with an arrow on it, and we can put a few, but one is good enough. Any light that begins parallel to the principal axis gets reflected off of the mirror and goes through the focus. And again, I've put a few arrows to demonstrate. In reality, when we do these, we'll only need one. We will always draw this light ray on when we're dealing with converging mirror diagrams. Second rule, and we'll always draw this diagram as well, any light that passes through the focus, so it goes from the object to the focus like that, when it gets reflected off the mirror, it will be reflected so that it's parallel to the principal axis. In reality, this is just the exact opposite of Rule 1. We can have light that passes from the object through the center of curvature. That light is always reflected exactly back on itself. So the light begins going from the object to the mirror, but when it hits the mirror, it goes back toward the object. This is the only light that will be reflected back on itself because we have a curved mirror. Those three diagrams, those three light rays, will be the most common ones, and in fact they'll be all we need in order to draw an accurate diagram of the curved mirror. Like I've already indicated, the object is represented by an arrow. It doesn't matter what it is, we're just going to draw an arrow for simplicity. The object is parallel to the mirror or perpendicular to the principal axis, so it stands straight up, it's not angled. The base touches the principal axis, as I've already said. The top has an arrow tip on it, so we know what's up and what's down. And we draw rays always from the tip of the object and reflecting off of the mirror. So once we get all this done and we put all of these diagrams on the same diagram, how do we know what the image actually looks like? Well, right here, if we have two of those light rays that connect and give us the image, then that's all we need. We don't always need to draw the light ray that goes through the center of curvature. So the point of convergence is dependent on the reflected rays, and I'll get to what that looks like in a second. So we had our first light ray coming parallel, then reflecting through the focus. I'm going to put this in green right now. This is not a point where we would have the image, because this second ray that goes through the focus, that is a light ray going from the object to the mirror, right here. And this light ray is going from the mirror out. So we'll ignore those. We have this light ray, like I said, going through the focus and then reflected. And it's those reflected rays that we follow back until they intersect. And we have the image right here. The image is always formed by two reflected rays. couple of housekeeping items. How did I know that the image pointed upside down from the original object? Because the bottom of the image and the bottom of the object are always drawn to the principal axis. So if this is below the principal axis, we know this image is upside down. The way we say upside down is that the image is inverted. If it was right side up, that is, if it was on the same side of the principal axis as the object, we'd say the image was erect. We can talk about whether the image is real or virtual. Real images form on the same side of the mirror compared to the object. This image is on the same side, the left side of the mirror, so this is a real image. We can talk about its location. The location could be outside of C, between F and C, between F and V. This one happens to be between F and C. And we can also talk about the size of the image. All we really care about is it the same size as the object, larger or smaller, based on the size, because everything is drawn to scale. This is a smaller image.